Hello class 10. Today we are going to do some numericals on resistance. So the first question we have is the diagram shows a cell of e.m.f equals to 2 volt and internal resistance R is equal to 1 ohm, which is connected to an external resistance of R 4 ohm. The ammeter A measures the current in the circuit and the voltmeter V measures the terminal voltage across the cell. What will be the readings of the ammeter and voltmeter when number 1 the key K is open and number 2 key K is closed? So here we have the figure. This is the cell, okay, and its EMF is equal to 2 volt, and this is the internal resistance small r which is equal to 1 ohm, and across its terminals, okay, the voltmeter has been connected marked by capital V, and from here the circuit has been made where the resistance of 4 ohm is kept. This is the external resistance. This is the key means switch, we can say key also, okay, and this is the ammeter. Now when the current will start flowing from the positive terminal, okay, the key has to be kept on. If the key is on, that is it is closed, then the current will start flowing and it will pass through the ammeter and again it will reach the negative terminal of the cell, okay. But if the key K is open, then the circuit is not complete, means the circuit has not been connected if the key K is open. So in the first case, the key K is open means the circuit is not connected. So if the circuit is not connected, then the current won't flow through the circuit, and hence there will be no reading of ammeter. All right, so let's solve it out. Okay, so here we have the figure. In this figure, when the key K is open, when this key is not closed, when it is open, the circuit is not connected, so there will be no flow of current. Okay, so if there is no flow of current, then the ammeter reading will be ammeter, since ammeter reading shows the flow of current, how much current is flowing through the circuit. So since there is no flow of current, so the ammeter reading will be equal to 0. Now if there is no ammeter in if there is no current flowing through the circuit and the ammeter reading is 0, that doesn't mean that the voltage across the terminal will also be equal to 0. Okay, so the voltage across the terminal will be equal to the potential difference of the cell, and the potential difference of the cell is e.m.f itself when the current is not flowing. When there is no current flowing, then e.m.f will be equal to the potential difference of the cell. Okay, so the potential difference over here is 2 volts. So the voltmeter reading will be equal to 2 volts. All right, so this is the case when the key K is open. Now if the key K is closed, when this is connected, okay, the key K is closed, then the circuit is connected, then the current will start to flow through. Okay, so when the key K is closed, the circuit is connected and the current starts flowing. All right, so when the current starts flowing, it has to flow through the resistance, external resistance of 4 ohm, and again it will flow through the internal resistance of 1 ohm, and these two resistances are connected in series. So in series we can directly add, as we have discussed it in the earlier class. Okay, so the resistance of 4 ohm and 1 ohm will be added and the result will be 5 ohms. All right, now we need to find out how much will be the ammeter reading. So in order to find the ammeter reading, that means we have to find the current. We have the resistance and the current will flow through the resistance with the potential difference of 2 volt, right? So we will use the Ohm's law over here, which says that V is equal to IR. This means that I is equal to V by R. Now V over here, the potential difference is 2 volt, and resistance over here is 5 ohms. Okay, 5 ohms. So I will be equal to 2 by 5, and 2 by 5 is equal to 0.4, okay, 0.4 ampere. Okay, since we are talking about the current I, so it is 0.4 ampere. So in the ammeter, the reading will be equal to 0.4 ampere. All right. Now, since we have already talked about the internal resistance, and for the internal resistance, there will be some voltage drop. Okay, so we know that voltage drop is represented by small v is equal to capital IR. Okay, from Ohm's law itself. So V is equal to IR. Over here, V is the voltage drop, R is the external resistance. So I into R means the current times the internal resistance is equal to 0.4 ampere times 1 ohm. Okay, so this is 1 ohm and 0.4 ampere is the current which is flowing through the circuit. That needs to be multiplied. So when you multiply, you will get 0.4 volt of voltage drop. So this is the voltage drop. Okay, 0.4 volt. But now since there is a voltage drop, that means what will be the total voltage, total potential difference on the, on the two terminals will be equal to what was the actual potential difference. It was 2 volt, and now there is a voltage drop of 0.4 volt. So you have to subtract it, and then you'll get the answer as 1.6 volt, which is the voltmeter reading when the circuit is connected or when the key K is closed. Okay, so these are your answers. Next we move on to question number 3. A cell of EMF 1.8 volt and internal resistance 2 ohm is connected in series with an ammeter of resistance 0.7 ohm and a resistor of 4.5 ohm. So over here, this is the circuit. You can see there is a potential difference. There is a cell over here of EMF 1.8 volt. Its internal resistance is equal to 2 ohms, and here this ammeter which also has some internal resistance, some resistance of 0.7 ohms, and there is an external resistance of 4.5 ohms. All of them are connected in series. Okay, what would be the reading of the ammeter? That's the question. And what is the potential difference across the terminals of the cell? So you have to find the potential difference and also the ammeter reading, just like the previous question. Okay, so since the resistances over here are connected in series, so we can say that the total resistance is equal to 2 ohm plus 0.7 ohm plus 4.5 ohm, that equals 7.2 ohms. And since the EMF is equal to 1.8 volt, so we can write EMF is 1.8 volt. And also we know that from Ohm's law, V is equal to IR. So I is equal to V by R. All right, V by R. Why? Because V, EMF is given, potential difference 1.8 volt, and the resistance is 7.2 ohms. And we need to find out the current, how much it flows. So this will be equal to, if you put the value, 1.8 is the EMF, okay, divided by 7.2 is the resistance. So 1.8 divided by 7.2 is equal to 0.25 ampere. Okay, so therefore the ammeter reading will be equal to 0.25 ampere. Now again, just like the previous case, since there is an internal resistance of 2 ohms, so there will be some voltage drop. So we'll write small v is equal to IR. Okay, IR means the current multiplied with the internal resistance. So over here the current is 0.25 ampere, which needs to be multiplied with 2 ohms of current, 2 ohms of internal resistance. When you multiply, you will get 0.5 volt of voltage drop. Now if there is a voltage drop, that means we have to find the potential difference by subtracting the voltage drop from the EMF. So potential difference will be equal to 1.8 volt, that is the EMF, minus the voltage drop 0.5 volt. So when you subtract it, you will get the answer as 1.3 volt. So these are the two answers. Answer A is the ammeter reading of 0.25 ampere, and the potential difference across the terminals will be 1.3 volt. All right. So we move on to the next question. Question number 10. Calculate the equivalent resistance between the points A and B if each resistance is 2 ohms. See, these kind of questions are very important. Okay, you'll get the resistance, resistors connected in series or in parallel. You have to find the equivalent resistance. Okay, this kind of questions are really important. So over here you can see the two resistances are connected in series and these two are connected in parallel, and you have to find what is the overall equivalent resistance in the 2 points between A and B. Okay, so over here you can see that the 2 resistors are connected in parallel. So we will find out the resistors connected in parallel using the formula. Okay, and that is 1 by Rp, that is 1 by resistance connected in parallel, will be equal to 1 by 2, that's the formula, isn't it? 1 by 2 plus another resistance of 2 ohms, that will be reciprocal 1 by 2. Okay, so 1 by 2 plus 1 by 2, that is half plus half, is equal to 1. Okay, so inverse of 1 is again 1 only. So inverting resistance in parallel, if you invert this 1 by Rp as Rp, you will get 1 inverse, that is again equal to 1 ohm. Okay, inverting Rp, you have to invert this value also, and when you invert this one, you will get 1 ohms. Alright, so this section of resistors is equal to 1 ohm. So over here you can see now this resistance and this overall resistance of 1 ohm is connected in series. Now when you have to add or get the result of the resistance in series, then you'll simply add the resistors value. So that is, resistance in series has to be added like 2 plus 2, and this one is equal to 1 ohm. So when you add, it is equal to 5 ohm. So this is the equivalent resistance for for the given diagram over here between the points A and B. So the resistance between the points will be 5 ohms. That's the answer. Next is question number 13, and this is also one of the most important questions. Okay, this type of question over here might be kind of difficult. Okay, but it's very easy. We'll try to simplify this kind of circuit diagram into the simplest one and try to solve it out. So calculate the effective resistance between A and B in the given circuit. That means you have to find what is the equivalent resistance between this point A and this point B. Over here, if you see, this 1 ohm is connected over here first, then you have a loop over here, all right, and there's another 1 ohm of resistance and it reaches point B. See over here properly, if this resistance goes and gets connected over here and comes over here, okay, that means this resistance of 1 ohm and 1 ohm, they are connected in series. Similarly, this 2 ohm and 2 ohm, these 3 resistances are also connected in series, and they are connected with this 2 ohm of resistance in parallel. Okay, let's try to understand it, making this circuit diagram in a more simpler way. It will be something like this. See over here, 1 ohm is over here. This 1 ohm and 1 ohm are connected this way in series, and these 2 ohm, these 3 resistances are connected in series like this way, and there's a 2 ohm of resistance over here in the middle, and there's 1 ohm outside. Okay, so let's see how much this resistance which are connected in series is equal to. So this is equal to 1 plus 1 plus 1 is equal to 3 ohm. So from here to here, okay, the resistance equivalent will be 3 ohm. Similarly here down there, 2 plus 2 plus 2 will be equal to 6 ohms. Alright, so this is 3 ohm, this is 6 ohm, and there is 2 ohm which are connected in parallel now. Alright, so connected in parallel, again the formula will be 1 by Rp is equal to 1 by 3, okay, 3 over here, 1 by 2, okay, there is only 2 ohms over here, 1 by 2, and 1 by 6, this is 6, isn't it? So 1 by 6. So 1 by 3 plus 1 by 2 plus 1 by 6 If you simply add it as a fractional addition, then you'll get it is equal to 6 by 6. 6 by 6 is equal to 1 ohm. That means the overall equivalent resistance of this much portion is equal to 1 ohm. Now here we have 1 ohm, this is equal to 1 ohm, and there is again another 1 ohm, which are connected now in series. So if they are connected in series, then resistance in series will be equal to 1 plus 1 plus 1, which is equal to 3 ohms. Alright. So I hope you have understood this. So there will be an assignment in which you have to do the similar kind of question. Alright. From exercise 8b, page number 201 to 203. These are the questions that you need to attempt for 5, 16, 17, 19 and 27. Alright. Thank you.